This is our last lesson on quadrilaterals, or our last lesson in Unit 7. And we are looking at, oh no, dreaded word, proofs in the coordinate plane. So you're not going to be actually like writing a proof like you're used to from triangles. You're really just going to be using formulas and what we did last time to kind of just show that certain things are true about quadrilaterals in the x and y axis. So we'll kind of show you what I mean with the second example on the back. But on the front, we're just practicing like with some of the different formulas. This will help us when we get to the actual like quote unquote proofs. Okay, so they gave me a picture of a kite here. Okay, and they told me in number 1 here that this is a kite. So think about what you know is true about a kite to fill in the coordinate of s. And this is what we did last time. I need to figure out what ordered pair is s right there. So just looking for an ordered pair on this first example. Now, like we said last time, you should go in and label where 4a, 2a, and 6a are. Okay, so remember you start at the origin. To get over here to point D, they went right 4a. So that's this distance, that's 4a. To get down to point F, they did not go left or right, the x value is 0, they just went down 2a. Picture's not to scale here. And then to get up to A here, they did not go left and right, x is 0, they just went up 6a. Okay, so if I use what I know about a kite, remember that the short diagonal here gets bisected. So if this was 4a, the other side is also 4a. So to get over to point S then, you need to start in the middle and go left 4a. So that would be a negative. And you do not go up or down, so it'd be 0. Okay, so now that we've filled in point S, we can kind of use and practice some of these formulas that we already know. So B says find the midpoint of AS. So that's this side right here. I'm just going to copy down the ordered pairs. So A is 0, 6A, and S is the ordered pair that we got up here for part A, which is negative 4A, 0. I want to find the midpoint. It would be useful to remember the midpoint formula. And if you don't remember it, maybe jot it down off to the left here. It's a giant ordered pair, and you really are just like averaging the x's and the y's. So you add the x's and divide by 2 to get your new x value. Ooh, had to write this real small, but same thing for the y's. y1 plus y2 divided by 2. That's the new y value. So first semester stuff, I just like to think of midpoint as averaging. We're trying to find, though, where is right in the middle on side AS. So if I plugged into my formula here, which is going to be a giant ordered pair, I need to add the x's. So I'm going to go ahead and label the ordered pairs x1, y1, x2, y2. Okay, so I need to do x1 plus x2, so that's 0 plus negative 4a divided by 2. And then I need to add the y's together, 6a plus 0 divided by 2. You always want to simplify on these, you guys. Just make it the best answer possible. So really, the 0 makes no difference. I'm just looking at like negative 4a divided by 2. So you'd actually want to divide those numbers and just write negative 2a. Same thing for the y value. The 0 doesn't matter. So it's really just 6a divided by 2, which is 3a. So as weird as that looks, that would be the midpoint of this side AS. Okay. Sometimes for these quote-unquote proofs, we will have to use slope. So let's remind ourselves of that formula off to the left here. Remember that's y2 minus y1 over x2 minus x1. Okay, we're using the same ordered pairs, so I've already got them labeled x1, y1, x2, y2. Let's go ahead and just plug that in. So I need to do y2, which is 0, minus y1, which is 6a. On the bottom, I'm going to do negative 4a minus 0, and then simplify. That'd be negative 6a over negative 4a. Negative over negative would just be positive. Here's how this simplifies. The a's cancel, and 6 over 4, I know that I can reduce that to 3 over 2. So that would be the slope of side AS. All right, I'm going to do the same thing for DF, finding the midpoint and the slope. Again, this is stuff that you'll use in your proofs. So let's copy down the ordered pairs of D and F here. So D is 4a, 0, and F is 0, negative 2a. All right, plugging into my midpoint formula, giant ordered pair. Let's label them x1, y1, x2, y2. I need to add the x's together. 4a plus 0, divide by 2. Add the y's together. 0 plus negative 2a, divided by 2. And that would give me, if I simplified, again, the 0 doesn't matter, so that's really just 2a, 4a divided by 2. And over here, oh, that's a 2. Negative 2a divided by 2 is just negative a, or negative 1a. Okay, so that would be the midpoint of DF. The slope of DF would be y2 minus y1 over x2 minus x1. And that would give me negative 2a over negative 4a, which again the a's would cancel, and negative 2 over negative 4 is just positive 1/2. All right, crazy looking answers. A lot of nonsense, I know, but we'll use these formulas and stuff to do proofs. So flip it over the back. Here's kind of like where we put it all into play. They've plopped the rectangle on the x and y axis right here, and they want me to use coordinate geometry to prove the following theorem. We know this, we learned it as one of our properties. In a rectangle, DC, which is that diagonal, is congruent to HP, the other diagonal. So really, we're just trying to prove in a rectangle that the diagonals are congruent. So here's what I would need to do. If I'm trying to show that two lengths are the same on the x and y axis, I need to use the distance formula. So I'm not using midpoint or slope. If I want to show lengths are the same, distance formula. The problem becomes I need to figure out what that ordered pair is for C and what that ordered pair is for D. They told me P and H, so I'm good there. Here's what I'm going to do. I'm going to label, just like we did last time, 2A and 2B, because I'm going to use that for point C and point D. So to get up to the ordered pair of H, they went right 2A, and they went up 2B. You guys know that in a rectangle, opposite sides are congruent, so DH would also be 2A, and DP would also be 2B. Okay, so now we can fill in point C and point D. To get to C, you start in the middle and you go right 2A. Do not go up and down. So 2A, 0. To get to D, you don't go left and right, so 0. You just go up 2B. Okay, so here's what I have to do. I actually have to do the distance formula twice to show that DC is the same length as HP. Okay, here we go. So I'm going to say length of DC here. And we're going to do it again over here to show the length of HP. I like to remind myself what the ordered pairs are. So D is 0, 2B, and C is 2A, 0. Okay, if you forget the distance formula, let's fill that in. x2 minus x1 squared plus y2 minus y1 squared. So let's label x1, y1, x2, y2. And when I plug that in, I would have x2 minus x1 would be 2a minus 0 squared plus 0 minus 2b squared. I need to simplify that down, so take care of the parentheses. So that'd just be 2a, 0 doesn't change it. That'd be negative 2b inside the second set. Now take care of your exponents. 2a squared, or sorry, 2a, yeah, squared is 2a times 2a, which is actually 4a squared. And negative 2b squared is negative 2b times negative 2b, which is positive 4b squared. Now, looks crazy, but actually that's as far as you can get it. You can't do the square root of both. It just doesn't work like that with all your radical rules. So that's the length of side DC, that diagonal, which is a disgusting answer. You have to do the same thing with HP. So H is 2A, 2B. P is 0, 0. Okay, so call that x1, y1, P, x2, y2. And let's plug it on in. All right, so I'd do 0 minus 2a squared plus 0 minus 2b squared. That'd be negative 2a squared plus negative 2b squared. Ignore that little mark out there. When you simplify this, same thing, negative 2a times negative 2a is 4a squared. And over here I got 4b squared. Okay, so I'm going to write a little blurb here at the bottom. I'm going to say, since the lengths are congruent, the diagonals are the same. Point proven. Ta-da.